Okay, so what we're going to talk about this week is the unit circle in particular. So what you worked on last week in the 6.6 task was just kind of talking about the, what you did last week, the circle and how you found, for example, these different ordered pairs that were around it. We talked about how to find radians. And so now we're going to apply that just to the unit circle. So when you read through this 6.9 task, it points out to you that we're going to be dealing with a circle that has a radius of 1. So when you read through that, it'll talk about that. It's going to have 12 spokes on the circle. So when you read through that. And you'll see that at the bottom here, they kind of draw for you 2 circles. There's 12 spokes on it. And they talk about this, they complete this right triangle. They call these braces when you read through it. But they created this right triangle. So in this first one, we have a 30-degree angle here. And again, just based on what we did before, it's 360 degrees all the way around, divided by the 12 spokes that we have. That's going to give us a 30-degree rotation for each one. So that's where this 30 degrees comes from. And so then this becomes a 30, 60, 90 right triangle. So I kind of have up here, remember about how to find the sides of your special right triangle. And so when you answer these questions on these 3 bullet points, that's basically what they're asking you to do, is to find the measures of the sides, and then they want you to find also the ordered pair that would represent this point B here. So I worked it out for you here. Since I know the radius is 1, that's across from the 90 degrees, so that's what you see here, 2x equals 1. I solved it, x equals 1/2. That would be the side across from 30 degrees. So across from 30 degrees, this side is 1/2. And then the side across from 60 is x root 3. Well, if x is 1/2, multiply 1/2 times the square root of 3, and it's just the square root of 3 over 2. And that will be across from the 60 degrees. So when I write my ordered pair for the coordinates of point B, it's x comma y. Well, the x coordinate here is root 3 over 2, and then the y coordinate is 1/2. And so that gives me that ordered pair. Now they want me to find, they're going to move B actually to this point instead of here. So now they created that new triangle for you. Well, remember, if each rotation is 30 degrees, 30 plus 30, that gives me this 60 degrees here. So if this is 60 degrees, that leaves 30 degrees up here. So it's still a 30, 60, 90 right triangle, but the orientation of my angles is different. My radius is still 1. That's still across from the right angle. So this all still applies. So x is 1/2, but this time 30 degrees is here. So now my 1/2 is here, and then root 3 over 2 would represent from B to C. So my ordered pair x comma y would be 1/2 comma root 3 over 2. So that's where I get that ordered pair from. Okay. Okay, so then it asks you on the next page, it says, based on the work that you did with just those 2 angles there, they want you to fill in all the ordered pairs on this circle. It's the same circle. So again, you could fill in the angles if you wanted to. This is 30 degrees. That was what we found in the second one. So each of these is 30, right? And on that first page, we talked about doing those 2 triangles where we had the 30 degrees there and then when we had 60 degrees. That's on the previous page. So now I'm just going to use symmetry, that's why I have this written here, to find the rest of these ordered pairs, okay? So remember, this is 1, 0, because my radius is 1, so those are the coordinates. You found these coordinates on the previous page, and these, and then this would be 0, 1. So now using symmetry, since these 2 triangles would have been the same, the ordered pairs are going to stay the same, but now because I'm in quadrant 2, that makes my x negative. But my y is still positive, okay? And then that would be symmetrical to the one down here. So again, this is why here x and y are negative, and over here. So what I did is in pencil, I put the ordered pairs for the triangles that would be symmetrical, and then in blue, I wrote the coordinates for those triangles that would be symmetrical, and then in red, I did the quadrantals. So that just means they're on the x and the y axis, and that's what you see here, okay? I showed some work over here about converting 30 degrees into radians, so I did 30 degrees times pi over 180 degrees, gives me pi over 6. Another way you could have found that is saying it's 2 pi all the way around the circle, just like we said 360 degrees. Well, 2 pi divided by 12 spokes, that means each spoke is going to go pi over 6. So I labeled that in purple here. This is pi over 6. This would be 2 pi over 6, and then I reduced it to pi over 3. 3 pi over 6, reduce it. 4 pi over 6, 5 pi over 6, and all the way around, reducing whenever you can, and that's what you'll see here as you study that. So basically what you guys are going to have to do eventually when you get into trig is you memorize. This is what we call the unit circle, well, part of it. And you're going to have memorized each of these radians, that this is pi over 6 and that this is pi over 2 or that this is 7 pi over 6 and what the coordinates are. And so they give you some practice here on the bottom. You have the circle at the top to help you. But again, they want the exact values. They don't want you to type it into your calculator and give the decimal approximation. So when they're asking you for the sine or the cosine, just remember we've talked about sine as y over r, but since our radius is 1, the sine is just whatever the y value of that coordinate is. So when it says the sine of pi over 6, till you get used to it, you're going to want to go, okay, here's pi over 6. The sine is the y value, and that's why it's 1/2. What's the sine of 5 pi over 6? So you go to find 5 pi over 6, and they want the sine, so it's the y value, and you have 1/2. So that's what you're doing as you fill these in. It's going to take some time to kind of get used to it, but it's something you got to memorize. I put a little asterisk here because I want you to remember on the bottom, the sine of 7 pi over 3, you might be like, well, I don't see 7 pi over 3 here. But remember, we can go around the circle many times. So what I want you to realize is that 7 pi over 3, having that same denominator that we had here of 6, if I multiply by 2 over 2, that would give me 14 pi over 6. So just remember, right here it says 12 pi over 6. So if I kept going, this would be 13 pi over 6. This would be 14 pi over 6. 14 pi over 6 is in the same position as pi over 3. So that's why down here, it's going to have the same coordinates as pi over 3 does. Okay, so I wrote that there just to kind of help you with that. Now the other part of the unit circle would be, what if we had only 8 spokes? So if we had 8 spokes, and that's what they describe here, again, please make sure you're reading through this, but when you have 8 spokes, 360 degrees divided by 8 makes them 45 degrees. So this becomes a 45 degree angle. So now I have a 45, 45, 90. So I wrote over here to remind you of those sides. My radius is still 1. And the side across from 90 is 1. So that's what I wrote here. X root 2 equals 1. I divide. Then remember, we have to rationalize because we can't have a radical in the denominator. And I get root 2 over 2. So that's across from 45 degrees. Well, remember, we have two 45-degree angles, so those legs, those sides are going to be the same. And then I'm just going to write the coordinates like I did before. This is x and y, root 2 over 2, root 2 over 2. My points on my axes are still going to be the same, but notice how the sign is the only thing that is changing on these coordinates based on what quadrant it's in. Now, in terms of the radian measure, just remember, we have 2 pi would be all the way around. If I divide it by 8 spokes, that gives me pi over 4. So each rotation here. So this is pi over 4. This would be 2 pi over 4, which reduces to pi over 2. Then this would be 3 pi over 4. 4 pi over 4 reduces. 5 pi over 4. 6 pi over 4 reduces. 7 pi over 4. And then 8 pi over 4 reduces to 2 pi. Now remember, I could keep going and say, oh, okay, this is 8 pi over 4. This would be 9 pi over 4. 10 pi over 4. 11 pi over 4. Just so you know that for the ones on the bottom. So again, on the bottom, they're going to ask you for these exact values. Now, this is something you're going to have to memorize, but initially, you kind of got to get used to it, and this is how you're going to get used to it. So you say sine of pi over 4. I'm going to find pi over 4 up here, and then the sign means the y value, so I would write my y value here. Okay, so all of these work the same. Now, again, I put an asterisk by the one you're going to want to, two of them you're going to want to pay attention to. One is this cosine of a negative pi over 4. So remember, if it's a negative, it means I'm going in clockwise direction. So pi over 4 would, that negative pi over 4 would be here. So that's why I wrote it's the same as 7 pi over 4 if I were going counterclockwise. And then 11 pi over 4, where is that going to fall? Well, we have 8 pi over 4 here, so this would be 9 pi over 4, 10 pi over 4. This would be 11 pi over 4. So my 11 pi over 4 is going to have the same coordinates as 3 pi over 4, which is what I wrote down here for you to remind you of that. Okay? So what we have here is basically the unit circle that we kind of broke it down into 2 parts just so you can start to learn it. Okay? When you do your ready, set, goes, they explain how to do it. So I'm not going to give you too much explanation here because they really do walk you through it. But when you get to your sets are going to be very similar to what we did here in this task. Try not to just go back to the task and copy it. See if you can do it on your own based on what you learned through the task to help you through it as well. Okay? Again, eventually what you're going to want to do is you want to memorize what this is. This whole thing is called the unit circle. And so next week what we'll do is we'll kind of put it together on one big circle where you're going to have, again, this part where you would have 30 degrees, and then we're going to have this part with our 45, but we're going to put these two together into one circle. Okay? So again, please just make sure you work through this task. I have these notes worked out for you on Canvas, so make sure you use them as you need them. And then try to work through the Ready, Set, Goes without looking at the answers. See what you can do, especially the sets, because this is where you have to begin to start memorizing these coordinates. It will really benefit you as you work through trig, whether it be next year or you know, when you're in college or whatever it might be. But it is so beneficial to know this as you move further in math. Okay, good luck, guys, and let me know if you have any questions.